Hi, I'm a data analyst at Netflix. Following the company's Q1 2022 subscriber loss, management identified the mobile app experience as a potential source of customer dissatisfaction. Poor app performance, buffering, crashing, and payment failure frustrate users and can push them toward cancellation even when they are happy with the content. The business problem I'm addressing is what aspect of the Netflix app experience drove dissatisfaction? And can we predict user sentiment from review tags? I translate this into a supervised machine learning task, binary sentiment classification. Review rates 4 to 5 stars are labeled positive, 1 to 2 stars are labeled negative. Neutral reviews are excluded for a cleaner classification boundary. The primary evaluation metrics are F1 scores, accuracy, and ROC-AUC. Stakeholders are Netflix mobile product and engineering teams. The dataset is the Netflix app review sample from Hugging Face, 5,000 real user reviews from Google Play and Apple App Store. It's 8 columns including star rating, review tags, platform, and date. After filtering to English review and remove duplicates, the working dataset is 2,256 reviews. The binary machine learning dataset contains 1,079 positive and 1,012 negative reviews, a near-perfect 52-84 class balance. The strength is it is a real user-generated task labeled via star rating, covers both platform, and limitations are there are only 2,256 usable reviews after cleaning, and ratings are heavily scrolled toward 1 star and 5 star with a few in the middle. So the first step is doing some data cleaning and text processing. So the general cleaning is to filter to English, remove NTP records, duplicate on content, text pre-processing pipeline, which includes turn into lower cases, remove URLs and punctuation, tokenize and remove stop words, and limit text. One important decision is I kept negation words like not, never, and no in the stop word remove step. Removing not from not working would flip the sentiment meaning entirely. I also add reviews, lens, and words content as a cultural feature, which reveals a useful patterns in the EDA. Now let's to the output. Figure 1 confirms the bimodal rating distribution. Most reviews are extreme. Figure 2 shows border sentiment cross increasing the dataset rating, but rather only agree with the actual label 63.1 of the time. And this is the key motivation for building a supervising machine learning model, rather than relying on rule-based sentiment alone. The most revealing analysis is the bigram chart in Figure 5. Top negative bigrams include keep loading, not working, video quality, and cancellation subscription. Top positive bigram include good app, love Netflix, and best app. This clearly separate technical frustration from content satisfaction and give the producing team sufficient area to act on. And for this are the top 20 positive and top 20 negative single word reviews. And this is for a word cloud for better visualize. Now, let's focus on figure 6. The negative reviewers write significantly longer reviews than positive one. Frustrated users have more to say, and this is also means negative review carry richer signal for the classifier. And now let's look at figure 8. So after feature engineering, I use logistic regression coefficient to identify the most predict terms. Top negative features not working, cancel, worse, terrible, loading, top positive features, love, great, amazing, best. These align closely with the bigram findings, validating the analysis. So, next part is the feature engineering and modeling. I use TF-IDF vectorization to convert reviews text into a numerical feature. TF-IDF weights words by how distinctive they are to a given review related to the full corpus. My configuration used up to 5,000 features, capturing both unigram and bigrams, and apply long normalization. The vectors are fitted only on the training set to prevent data leaking, producing 2,591 features. I compare three models: naive Bayes as a probabilistic baseline, logistic regression as an interpretable linear classifier, and random forest as the reasonable approach. All models used a 80-20 stratifying training test split and five-fold cross-validation. So we can display the model result here. The logistic regression is the best model across every metrics. The standout result is the ROC-AUC of 0.9182, above 0.9 is considered excellent, meaning the model correctly distinguish positive from negative reviews 91% of all the time. Accuracy is 84.3, and the weight F1 score is 8.83, with balanced performance in both classes. The learning curve shows the training and validation score converting, indicating the model is not overfitting. Random forest shows that higher variance in cross-validation, making it less reliable on these data sets. Now I want to give some business insight and recommendation. First is the fixed-driven performance. First, keep loading not working and video quality dominant negative backgrounds. App stability in the primary driver of one-star review. Netflix mobile engineering team should treat buffer and playback failures as a top priority. Simplify payment and account management. Cancel subscription is among the top negative backgrounds. Billing confusion and failure transaction quite frustrating that directly drive churn. Netflix should audit the in-app payment, follow and improve error messaging. Deploy the settlement model as the monitor tool. With the ROC-AOC of 0.912, the classifier will identify negative sentiment. Deployed as a automated pipeline, it can score new reviews daily and alter the performance team when negative sentiment spikes. Enable faster response before issue escalate. Using negative review as a bug tracker, since dissatisfaction user write long, more detailed review, and NLP tagging system that characterize negative feedback into issue buckets would give engineering a data-driven prioritized backlog. And also investigate platform difference. The 80-20 Google Play vs Apple split warning the platform's segment analysis. If Android users are disproportionately negative, this likely signal platform specific bugs need to dedicate fixed. So to close, analyze the 2,256 Netflix app review using a full NLP pipeline. The EDA shows the technical issue, buffering, crashing, and payment failure as the primary drivers of the dissatisfaction. The logistic regression classifier achieved 84.3 accuracy and the ROC-AOC of 0.912, demonstrating that user sentiment can be reliable predictive from the review text alone. Deployed as a monitoring tool, this model gives Netflix production team actionable real-time intelligence to reduce negative reviews and lower churn. Thank you.